So thanks for coming to this tutorial. So this tutorial will be about building R packages. So if you're really good at that, then maybe you will not learn too much. Okay, so I won't be, upset if you check out another one. But if you're not really good at that and you want to learn how to build R packages, then hopefully you will, learn something enough to start building your own R packages. So the title is is package development with RHub. So RHub is actually a service. It's a web service, which is a pity because the internet is really bad here. So some of the stuff you will not be able to run, I guess, because you will just not be able to connect to the web service, which is a pity. But as for myself, I'm streaming all the traffic through my phone now, so hopefully that will be okay for at least running it here, and then you can run it at home. So RHub is a web service that helps you a little bit with building packages. But really, most of the tutorial is not about RHub, but it's just about how to create our packages, really. Okay. So yeah, why don't we start, right? So this is an experiment. Sorry, this is an experiment with the tutorial. Without slides. I'm often sick of switching back and forth between slides and code. So we'll just have the code and some text at the same place. We'll see how it works. Okay. So why would you want to create an R package, right? How many of you have created an R package already? Almost all of you. What are you doing here? Exactly. No, kidding. Seriously, if it's too easy, then don't. Anyway, but then you know the answer to the question, right? So why would you create an R package? Why did you create yours? I mean, there are a number of reasons. Not necessarily in the order of importance, but it's good for encapsulation, right? So if you write a bunch of code that you want to move around, use it in different projects, you want to give it to other people, to install and run, then it's just a good, box that you just put the code inside that, and then they will be able to install it easily. So it's good for that. It's good for documenting code, and that's just simply because there is infrastructure for documenting code within packages. Okay, and there is not much infrastructure documenting code that is, outside of packages. I mean, there is some. You can always write, text files and stuff, but, it's a lot more streamlined if you have your code in a package, if you want to, write documentation, which is a good thing, even if you just use it for yourself. Testing code is so much easier if you have your code in a package. And again, that's an infrastructure reason, is that most of the testing packages, most of the packages that helps you with testing, or most of the testing solutions, I should say, work best if your code is in a package. And versioning code as well. So, if you have a long-term project, then almost always you use different versions of that code or of that data, for different things or for different projects. And it's having it in a package all in one place and assigning a single number, to that snapshot of the code and or data is just a nice way to organize your work. Okay, so how you create a package? So a package it's basically just it's a bunch of files. There are different tools that helps you create like an empty package that has a minimal infrastructure in it. So this is two of them. If you use the RStudio IDE or some other IDE, I suppose other IDEs have the same thing, then usually you will find something in the menu when you have new project or something like that in the RStudio IDE it's new project, and then you can just select that you want to create a new package, and that will create like a minimal set of files template files that you can use, to create your actual package after that from that. If you don't use the RStudio IDE, there are other ways to do that. One of them is the DevTools package. So if you don't have it and you're lucky with the internet, you can install it. Just install .packages DevTools. And the DevTools package has a function called create, and the create function, creates a package. So we will use the DevTools package a lot in this tutorial because it deals with packages. Okay. We will do this as an exercise, okay, later for yourself. Create your own package. And you can choose either way, to do it. So once you created your package, template, then you can already look at it, and you will see that there are different parts. Maybe the file to start with is a file called description in all capitals. So that's basically the most important meta information about your package. And most of these fields are optional. So if you're creating a package for yourself, I think only actually package, which is the name of the package, and maybe version are needed, and the rest are not. So if you want to, I want to do this incrementally, then you don't have to, fill in all the fields at once, but you can, start something small with something small, and then you can, fill them in later. Anyway, so this file, here is an example. I will just go down, okay? So this is an actual package. It's called RHub. This is the R package that you can use to connect to the RHub service. So this is the description file of the RHub package. Can you read this in the back? Yeah, it's good? Okay. So this one has a bunch of things, obviously, but again, you can keep it minimal if you want as a start. So the name of the package is RHub. There are some restrictions, how the name can look like. It has to start with a letter, blah, blah, blah. It has to be one word, and so on. Then there is something called the title, which is, it's supposed to be a one-line-ish, one sentence-ish short description of what your package does. This is more important if you want to share it with somebody, obviously. If it's for yourself, it's not so important. Then there is a version number, which can be, a bunch of digits, a bunch of numbers separated by dots or dashes. And this is the version number of the current version, of your package. If you use some kind of source control system like Git or SVN or something like that, then as you develop your package, obviously different stages in your source control system will have different versions. So this is the version we start with. This one has the current version is 1.0.1. There's a lot of there's a lot of writings on the internet about how you choose your version numbers, but I wouldn't go into that today. That's a little bit out of scope. The point is that I think the most important point is that if you change something small in your package, then you bump the numbers towards the end, and then if you change something big in your package, then you bump the numbers from the front. So if you completely rewrite it, then you would bump the first number, and it would be 200. So that's the essence of it, basically. Okay, the package has an author. For this one, it's me, and the package has a maintainer, and that's again me. It's a little bit different, syntax, because the maintainer has to have an email address. Again, these fields are basically only important if you want to publish this package in some proper, repository that R supports, like CRAN or Bioconductor. For yourself, it's not so important, obviously. Then you can have a description, which can be, a number of sentences of what your package does. You can have a license field, which, if your package is an open source package, then you can state your open source license here. Your package can have a URL, which is very useful. It's not required, even on CRAN or in a repository, to have a URL, but it's really useful to have, because if you have actual users, then that's the place they can go to. Okay, and because otherwise they will only have your email address. So if they only have your email address and they want to, they run into some trouble with your package, that will bother you. But if you have a URL, that will go there first, at least. There's a bug reports field, which is also important. It can be a URL for an issue tracker, or it can be an email address, if you like, a different one. And that's where users are supposed to report bugs. There's an encoding field, which I will not go into, but nowadays pretty much should be UTF-8 all the time. It only really matters if you have non-ASCII characters in your description and other files. Okay, now the interesting stuff is this imports, for example. So imports means that your package uses other packages to do, its work. And then if this is the case, then you need to declare what these other packages are. Okay, so this package is a pretty small package, but it builds on a lot of other packages, so it has a long list of imports. And the good thing with this is that a lot of tools that deal with packages use these fields to automate things. So if you list your dependent packages here in the imports, and then somebody else wants to install your package using the standard tools like install.packages, or just from an RStudio menu, then the package manager, these tools will know that your package needs all these other packages, and they will just go and automatically download and install those as well. Okay, so whenever you use another package, it makes sense to list it in the imports. And then there is something called suggests, which is very similar to imports. It's also a dependency, but it's a weaker kind of dependency. So basically, loosely speaking, it means that your users won't need these, but somebody who wants to actually work on this package and who is a developer, they will need it. So one example is, for example, the test.dat package. So that's the testing engine. If you write your unit tests in your package, your unit tests will use this engine to actually run the tests. But the users will not run tests, right? So they will not need this package. Anyway, this is a technicality, but that's the difference between the two of them. Okay. So there are some other files and directories there, and I'll just go through them very quickly, and then if you have, your IDE that can create packages like RStudio, or you have the DevTools package, or you can download it, you can just try to create an empty package and see, these files for yourself, although most of you have created packages already, right? So you kind of know what these are. You know what these are, right? Anyway, so there is namespace, which is it's a technical thing, and if you use a tool called Roxygen, then you never actually need to touch it manually. So it's automatically generated, but it has to be there in the package. So it's good to know about it, that it exists. And we'll talk about it more a little bit later. There's a license file, possibly. Sometimes you need it, sometimes you don't need it. This is, again, a technicality which you can read up on if you need it. There is a file called readme, or readme.md. Usually it's called readme.md nowadays, which is basically a summary, like the first page of the manual, something like that, introduction to your package. And again, this is optional, but it's really nice to have it because this is usually the place to start. Okay, so if you're looking at a new package, and you don't know where to start, it has a bunch of functions, it has a bunch of manual pages and stuff, but it has a readme file, a readme.md file. The readme.md file usually, has a high-level description of what the package does, what the most important functions are, and there are a lot of articles on the web and everywhere on how to write a good readme file and so on. So I will not go into that either. Okay, so there is a directory called R, which is probably the most important for you because that contains the code. Okay, so that contains the code in multiple files probably. So each file has an extension called .r, capital R. It's good to break up your code in multiple files because it's just easier to handle them. In some logical way, if you have a big package, then break up your code into multiple files. There is a folder called man, which is the documentation. That's the manual pages. So if somebody is using your package and they're interested in how to use this function or that function, they will just go to the manual. They will see basically all the files that are in the man directory. But the good thing again about this is that we can auto-generate this with Roxygen. So the advantage of that is that Roxygen has has a lighter syntax than the original syntax of the manual files. So the original syntax of the manual files is really heavy. So you need to write a lot of syntax and not so much text. Okay, not so much actual meaningful, stuff. Whereas, with Roxygen, you don't write too much syntax, you just write the actual text, which is nice. It's also true that if you use Roxygen, then the documentation is next to your code, so it's not in different files. You will see that shortly if you haven't used that yet. The tests directory can contain your unit tests, and then there's potentially a data directory that can contain data that you use in your package. Some packages only have data, actually. If you want to share data with somebody and you still want to make use of, the encapsulation of the R package, then you can just put that data in an R package, and then you can have other packages can depend on it, for example. So if you ever used, I don't know, the New York City flights package, that just has data. It has the flights, in and out of New York City in, I don't know, in a month or a year or something like that. So there are a lot of, data packages on CRAN and other repositories, actually. But you can also have, a mixed approach, so you can have code and data in the same package. The src directory can contain compiled code if your package has that. Most packages don't, so this directory just doesn't exist. And there is an inst directory, potentially, which is basically anything else. So whatever you put in there, it will be installed together with your package. A couple of things are forbidden. Some names are forbidden, like the names that would, interact badly with the other files. Like you cannot have a Falcom namespace in there because that would, interact with the other namespace file, because that will be copied to the same place. But other than that, small restriction, you can put whatever you want in there. So if you have some other files and stuff that you need for your package to run, you can just put it in. Okay. We are close to creating packages, right? Yeah, almost there, just a little bit more. Okay, so an R package can exist in different forms, right? When you create one with DevTools or say RStudio or whatever, then it will just create you a directory tree, on your machine. So that's one form. So that's like I called it package directory. So that's a directory tree with all the files, that your package has. And then there is a process called building, which you normally run with a command, R command build, from your shell. It's a lot easier to run it from DevTools because you don't need to leave R. So you can run it from within R. If you use DevTools, you need to say DevTools : build, or just build if your DevTools package is, loaded with library. So that builds the package, which means that it just puts together all the files, in those directories into a single file. And this is good because you can give this single file to somebody else, and then they can install it. Okay, so that's what building means. And then there is something. There's another command called R command install, which installs a package. So you would need to do it for yourself, or if you give your package, single file package to somebody else, they would need to run R command install to be able to use it. Okay. So what this does is that it extracts this single file, this compressed file, and it puts it in a certain place so that R can find it. Okay. And if you do that, then in R you can say library, my package or whatever your package, the name of your package was, and that will load your package, and that means that the functions of your package are available to use from R. Okay. So that's just the rest, with DevTools. So with DevTools, you would say DevTools build, you would say DevTools install to install it, and then the same way you would load it with library, and then you can call, your functions. Okay, one of the nice things with DevTools is that, I will say this in a sec, is that, so this cycle is a little bit long, to do it, and sometimes these things take time because you need to, create this single file to build it, and then there's an install process, which at least takes a couple of seconds. But if you have a big package that has a lot of compiled code, say, then, the install process will always recompile this code before it installs it. So this process can be lengthy, and it's not really convenient if you are just developing the package and you want to, want to work with the latest, version of your code that as you are writing it. So the nice feature with DevTools is that it has a function called load all, which basically kind of emulates all this. So it doesn't really do the build, it doesn't really do the install, but it just pretends, and it gives you an environment, that is similar to what it would look like if you did all this and you loaded the package. So to cut it short, while you're developing your package, all you need to do to get a new version, into your R session from your edited files is to call load all, which is pretty good. I mean, if you do it, because you do it pretty quickly, right? You modify your functions and then you want to, work with the new version all the time. So frequently, actually, you do this that you would probably want to define like a small shortcut for it. Like if your editor can have a shortcut, you can do it in your editor. If not, you can define like a very small function like L or something that you can reload very quickly. Anyway, yeah. Tricky question. It's not a fair question, actually, but it's just something to think about. So you put your code in your R package, right? So that's just, R files, .R files, they're there. So when is this code actually evaluated? What do you think? Because a lot of things are happening with this code, right? So first, when you build the package, we take all these code files, we put them in in the tar gz file. And then you install them, so you take them out of there, and then, you put them in an installed package library so that R can have access to it. And then you load the package. It's just the end of this is cut off. I'm not sure why that is. It's just a window. All right. Anyway, so when you load the package, you say library, things happening then as well, right? Because R goes there, in the library, and then finds your package in the library, and then, takes that code in. And then you also call functions in your package when you say, my package, my function. And that's when the code is actually running, right? So you would think that it's evaluated then, but obviously it's a tricky question, so it's not. Yeah, so when is it evaluated? Anybody has a guess? It's really tricky. Yeah, it's install time, actually. Yeah. It's just, this is a design choice. It's just the way it works, basically. It has advantages, disadvantages, but this is what happens, So you have your R code in your files, and when you install the package, R actually runs all that code, okay? It runs it in a certain order, so if you have a lot of files, and the default is alphabetical, actually. So if you have a number of files, it will just, take all your code files alphabetically, take all that code, and it will evaluate that code, okay? So now this is tricky, because what do you have in your R files usually? You have things like this, right? Like you're creating, in your package, you're creating functions that you would call later, right? So what does evaluation mean in this case? It just means that it just creates the functions, right? So all your functions are created basically at install time. And then they are saved in the installed package, in the package library. And when you load the package, there are no new functions are created actually when you load the package. I mean, you can work around this, but by default, there are no new functions or any other objects created at that time, And this has some interesting consequences. For example, if you have some code, I'm not saying that this is very useful, but sometimes it's useful and it's good to know about it. So if you have some code that is outside, it's not like the other code that creates functions, but it's like just basic R code. So if you just say print, it's really hard to type with one hand. Oh. Anyway, so you get the point. So I'm just printing something here. Okay, so this will run at install time. And sometimes actually this is good, because what you can do is that, for example, you have some kind of pre-processing step, before you're creating your actual final version of your data or function or whatever, then you can run this all in install time if you just put all that code, outside of a function, or we run it at install time. But most of the time, it's actually a pain if some packages do that. And that is because what happens is that you have an installed version of the package, that was created potentially using other packages, at install time. And that's not really intuitive if you, for example, update these other packages later after you installed your main package. Okay, so for example, R has a class system called S4 and has other class systems too, like the R6 classes have the same feature, that you create your classes, at install time, okay? But if your classes depend on classes in other packages, okay, then that will depend on those other packages that were, the versions of those other packages that were present at install time, forever. Even if you, update those packages later, your code will never be different, never be updated. Anyway, this is a peculiarity, but it's just sometimes good to know about. If you run into strange problems, then this is often the reason why things, work strangely. Anyway, the other thing that you can do with an R package is something called check. I should put this more to the top. Okay, so there is an R command check, and of course then DevTools has a function called check, so you can just call that, And this does a bunch of syntactic, checks to make sure that your package is in a usable state. It doesn't, obviously it cannot tell if your code is good or if your data is not so good or anything like that, but it will just check all the syntax that is in all these meta files and code files and so on. So it can check that your code is valid R code, for example, which is good because then you can make sure that, you won't give, broken code to somebody else. But it also checks your description files, for example. It checks if you have a valid package name. It checks if you have, a valid version number. It checks if all the imported packages. So if it checks if the imports field is good, and so on. It does a lot of syntactic checks. So it's a really useful tool. It's basically a linter tool if you are familiar, if you're from other languages. Okay, so why don't we do this exercise now, assuming that you have your IDE. So the exercise says that you create, this is my favorite package. This is actually an existing package, so we're kind of recreating it, but never mind. So it will have a single function, say, in the first version, which is called praise, and it will just randomly praise the user. Okay, so it will be something like this. You would call praise, and then it will just stick in a random adjective that, you are remarkable or terrific or whatever, or great. Is that good? You want to? I guess for people who have created packages already, this is kind of boring. But if you want to try it and go ahead with it, and then try. Shall we do this or not? So basically, this just means, that you just call, DevTools create, or, you create it from your IDE, and then, go to your description file, edit all the fields, and go to your R file and, implement this code, which is mostly trivial, I guess, if you did R coding. Yeah. If you like, yeah, whatever. So obviously, if you don't like this package, so you can create, another one. It's fine, whatever. It's not the point of it. Then, yeah. That's a real package, but you don't have to install it. Don't install it. No, we will create our own version, okay, of it. Just pretend, I shouldn't have told you it exists, but just pretend it doesn't exist, and we just create it now, okay? And if you have problems with something, you know, I can just go around and help, you know, if you get stuck. And of course, you will have to compile, you know, a list of positive adjectives, you know, to sample from to do that. But it doesn't have to be a long list. It's okay if it's just a couple for this purpose. Yeah, so we create with DevTools create. That was somewhere in the very top. So if you have the DevTools package installed, that you can just say, you know, DevTools : create. I think you will have to supply a package name. So if you want to call it praise, you will have to say praise there, and it will create a directory in your current working directory. You know, that will be the package itself. If you don't have it installed and you are lucky enough with the internet, then you can install it. So I started doing it too. So if you created your package with DevTools, it's actually, one field is a little bit different than what I showed you. There's this authors @r field. So that replaces basically the authors and the maintainer field. It's just one, you know, and it just looks a little bit more messy, but you get the idea. You write your first name and your last name and your email address there, and then basically you're done with that. For now, basically, you can just leave all these as they are. You don't need to actually fill them in. Okay, so that's one version of it, right? So, for example, here you see that the top part, you know, when I create the adjectives, so that's not inside the function, right? So that runs at install time. So this is fine for now, but if you just imagine that we are taking these words from another package, say, you know, then that can cause some issues because this runs at install time, and then, you know, it uses the words from the other package, you know, as they were at install time. So if you want to update your words later, it's not enough actually to update the package that has the words because they were, you know, put in this package at install time already, and it will stay there forever. You need to reinstall this package as well. Okay. Anyway, so this is one implementation. Hopefully, I haven't tried, hopefully it works, but let's try it. So with DevTools, you can just say, you know, DevTools, if I can type, load all. Oh no, I need to set the working directory inside the package, right? And then I can run, load all, which just says loading praise. And that means that this praise function, and also actually the object that contains the adjectives, so those are available for me now, so I can just call praise and check that my implementation is correct. Yeah, I mean, you could put a period at the end, I guess, but it's okay. Yeah. Oh yeah, sorry, that's a distraction. It's just the amount of memory the R process is taking now. It's just, yeah. Don't worry if you don't see that, it's good. It's not part of the package or something. I should have removed that. Anyway, so you see load all is great because you go back to your code and you just modify it and then you go back to your terminal or your IDE. If you are in your IDE, then you're just in the IDE all the time, of course, but you switch between your editor window and your R console, where you actually run the code and you can just say load all and you get the latest version automatically. It tries to be smart, so if you have compiled code and you change the compiled code, it recompiles it. But if you don't change the compiled code, it doesn't recompile it. This is not 100%, but most of the time it works. So it's a good thing. It's a good thing to use it because otherwise, going through the build, install cycle, and then library and so on, and it's very hard to unload a package. Once you loaded a package with library, often you basically cannot unload it, and then that's why you need to quit R, and then you need to start another R, and stuff like that. Some packages you can unload, but a lot of them you can't unload. Anyway, point is that DevTools load all is great. So you can do, if you want to build your package, you can do build, DevTools build. And then this would just call R command build, basically. And in the end, it will create this file that is in the bottom. It's called praise, The version number is a little bit awkward, and that's, that's a decision. That has a purpose that it's awkward. It's awkward because some of the tools that deal with packages will warn if they see this version number. So it forces you to change it to something meaningful, basically. So for example, you cannot submit this package to CRAN because CRAN will warn you about this 9,000 there. It's just a technicality, but it's good to have it there. So that creates this file, this praise underscore blah blah file, targz, which is a package file in itself. You can give it to somebody else, and they can install it the regular way. They install our package files, and then they can run your praise function. I'm omitting some important details that are coming later, but anyway. So that's build, and then there is install, because our package is not installed yet, is it? It's not, right? Because we just do DevTools load all that pretends, this whole chain, but it doesn't actually do it. So it's not actually installed on the machine yet. So if I quit this R session, or even as just say library praise, that will not work. Okay, but if I want to install it, I can just call DevTools install, and that will install it if I can type it. No, what's going on? Okay, I don't want to install it now because I was not very smart and I gave it the same name as the real praise package. So if I install it now, it will override that. So, but if you can install it if you don't have the other praise package, although you might. Yeah. Anyway, so that's install, and then there is check, right? Which I said in the end that you can try to write check, run check, DevTools, check, which runs this package check. Okay, so what do you think? Is our package a good package? We will see according to this check. Is the syntax all okay, or is it Oh, there's one thing coming up already. Oh, there's just one thing. That's perfect. Not too bad. Okay, I was lazy. I didn't add a license file. You see there's a warning there. It says the license file is missing. Yeah, but that's easy to fix, right? I just go back to the file, or no, that's specification. Sorry, the license specification is missing. So I can just go back here. Yeah, reread it. Oh yeah, because we said what license is it under, and we just say whatever. GPL2 is fine. I don't know if it's fine to remove it actually. Maybe it's fine to remove the line for our purposes. Maybe not. I'm not sure. Anyway, so that's not too bad. What did you get? You get like a cleanish check, unless you made some mistakes, right? I think you got something similar. Okay. Okay. Are you okay to move on? Okay, so this is something a little bit different. Well, I just wanted to include it because it's important and it's good to know about it. And also some of these services that I show you were built in the same project that our hub, the service that hopefully we will be able to try later, is built. So finding code and reading our code. So why is this important? Because it's important because that's the most efficient way to learn how to be a good R coder, or any coder basically, to read other people's code, and code that it's good. That's the greatest thing, in my opinion, in open source. It's not that it's free, but you get to see all these software products, that are sophisticated and mature, and you can see all their source code and you can learn from it. So that's one of the greatest things in open source software, I think. Anyway, so where do you learn? Where do you find R packages, and how do you read, their code? You can download them and then you can read the code, but that's not very efficient, if you want to search for some kind of, if you want to search for some specific code, or if you want to search for some specific R packages or R packages that do something. So then there are some services that you can use. So I just mentioned, there's more of them actually, but I just mentioned two of them here. One of them the first one because I mentioned this because I built this one. So this is just a website, that has all the R packages and their meta information, which is not so important actually. The important thing is that it has a search bar on the top right, where you can search, and if you want to, find R packages about, I don't know, lasso regression, then you can just search there. And my phone is pretty good with the internet, so it's pretty fast. You find some packages. So the important thing with the search is that if you want to do good search, you have to have ranking, right? You cannot just have, like a naive search that's basically just a pattern, search in the metadata or somewhere else. But you need to rank these packages. So the good thing about this website is that it tries to rank the packages, according to how many people use them, how many times they are downloaded, and so on. So you get, hopefully, the better ones towards the top. And this is an important issue nowadays because, we have about 10,000 packages, and there are a lot of packages that do similar things, very similar things. So it's just good to know how to find, the ones that are good, or hopefully good. I mean, who knows? The other one was rdocumentation.org, which is more. It does more stuff. It also has search. I think their ranking is not as good as mine, actually, but that's just a personal opinion. I mean, it's really hard to evaluate a ranking, right? It's just, I'm searching for stuff, and I'm just not finding the right things. But anyway, but it's decent, you know. And then they have a lot of other stuff. They have all the documentation. They just don't just have, you know, CRAN packages, but bioconductor packages from GitHub, and so on. So if I search here for less, so they also search for functions, not just packages. So you will see that they will find some, you know, find some packages, or less so too. So you see, it's a different ranking, right? So it depends. Yeah, on your application, which ranking is better, but it should be similar in the end. And they will find you some functions as well. Okay, so it is also often useful to search the code. And that's because simply, you know, you want to use some function from useR or from somebody else's package, and you just want to know how people actually use them. Because sometimes it's just hard to know that from, you know, examples and the other documentation, and it's just good to see actual, you know, usage of some functions and code in general. So there is, if you just go to GitHub. And on GitHub, in the GitHub search bar, you know, on the top, I should probably make this bigger, right? Anyway, here on the top, you just write your search term. Say, this is code search, right? So we want to search for, say, we want to search for praise. How do people use this, you know, function in their packages? If they do, most of them don't, obviously. Anyway, so, and then the trick is that there is a special user on GitHub that has all the CRAN packages, and that user is called CRAN. So if you write, you know, user:CRAN here, then it searches the code in the repositories of this user, and it will give you back all the hits. And you will find different things. The first thing is, you know, it searches repositories, so that's basically the whole package. That's the first hit, right? But there's also a tab called code. So if you go to that one, then you will see the actual code. Okay. Well, this is from the praise package itself, so this is not very informative, right? And a lot of them are from that actually. Okay, let's go down a little bit. Oh, here's another one. Okay. So this is from the test.dat package. You see, they actually defined their own praise function. You know, but they also use, you know, our praise function, right? So they randomly choose, you know, between these versions of praises. Obviously, when you search code, praise is not the best, you know, thing to show, but you get the idea. The idea is that if you're lucky enough that your function name is something that is searchable, because some of them are not easily, you know, because they're just too short and not specific enough, and then you will find a lot of, you know, stuff that is not the thing you were searching for. But if you're lucky and your package name is specific enough, then you will find, you know, code, and you will find basically. So this is not very smart code search actually. So you cannot say that you want functions and stuff like that. So it's something, but it's not optimal. That's all. That's, as far as I know, all we have for code search basically currently. Okay. Yeah. Yeah, you can find them here. Yeah. It's basically a mirror that is synchronized, you know, frequently. Yeah. It actually has, now that you ask, it has some pretty nice features. So if you just want to go, you know, so if you want to go to a certain package, you can just go to, you know, to this CRAN user, which has everything. It's an organization actually. It says unofficial mirror of all CRAN packages. And then you can just click on the package, or you can just type in the package name in the URL here. So say, I don't know, DevTools will take me to the code of the DevTools package, okay, which you can browse. So if you are interested, you know, in how I don't know, DevTools implements, load all or whatever, then you can just go here and see it. I guess you are usually more interested about, other more useful stuff for data analysis. But if you're interested how, I don't know, whatever, dplyr does something, you can come here and read about it and read it. Okay. So the other thing that you can do with this mirror is that if you use Git, that you can clone it, and then you can add your own, extensions and patches and modifications, if you like, to your favorite R package that is in there, and then you can submit that to the author. Although in this case, it's usually better to get the code from the original, repository of the author, because this is not that, right? So this is just a CRAN mirror. So if I went here for DevTools, this is not the repository where DevTools is developed, right? So that's somewhere else. I guess that should be here, under the author's name, right? So this is the original DevTools. The CRAN, the CRAN user only has the released snapshots, not all the development versions. But anyway, the point is that you can download this code either via Git if you use Git, if you want to do that, or if you don't use Git, you can just come here and say download zip, and then you can just download it as a zip file, it's basically almost the same as the Targi zip file that was there. It's just it's a different format. You can't directly use this with install.packages and so on, but you can uncompress it, and then you get a package tree, right? And you can work with that already. You can use, DevTools build, DevTools install, DevTools, load all, and so on. So you can get a package like this. If the package is on CRAN, you can also go on CRAN, and just download the source code. If you want to do that, that's fine too. Okay. I'm basically talking about all this. So here's the next exercise. So find an R package that you like on GitHub and download this source code and uncompress it, and then try DevTools on it. It's best if you have Windows and you don't know, or if you have R tools installed. So that's like an external set of tools for Windows. Or if you know that you don't have it installed, then it's best to choose an R package that doesn't have compiled code. But that's easy. It just shouldn't have a source, directory. So if you go to GitHub, you can still download it, but you will not be able to install it or load all it if you don't have the compilers on your machine. So I suggest you download something smallish. So don't download dplyr because it takes forever to compile, or ggplot or something they also tend to have a lot of dependencies. At least, I mean, some dependencies. Oh yeah, of course, I forgot. Only I have internet, right? You don't. Yeah. I wonder if I would stream everybody through my phone. No, probably not. Yeah. Sorry about that. Yeah, thanks for telling me that. So let's just go back to the praise package then. We can't really download stuff, right? You can't even browse. I forgot my internet was working so well. It's like, okay, so this is an easy one. I said let's fix all the check failures, but there were no failures, right? For me at least, there was this license thing, but then I added that, so that's good. Sometimes you have, more failures, and then as you start writing your package, actually, add actual code to it and documentation and data, you will have more failures to check. And even if you don't want to, submit this package or release it in an official repository, it's good to run this check because sometimes it will just, uncover problems that you otherwise don't notice. It's like it can uncover things like a mistyped. Let's see that. Okay, like a typo in a function name, say. So, whatever. There's an extra character here. So if you build this R package and then install it, no one will know until they try to use the praise function. They would have to load the package and call the function to see if it's not working. And obviously, if you have a large code base, not all of the code is running all the time, right? So you can have these kind of typos, hiding everywhere. But one of the things that our command check does is that it checks that you don't have these typos, and all of your, references to functions and objects are, to actual objects that exist. So if I run the check again here, then this should come up that this is not good. I even messed up the license. It's not in the standard form. Yeah, you see, so the license, the way I added it is not good. You should write it like that. But anyway, that's a minor thing. The important thing is that you have this other note here. Where is it? It's here. That says no visible global function definition. So it means that it tried to interpret, this symbol, but I just couldn't find it anywhere, which is no wonder because it doesn't exist, right? So anyway, the point is that it makes sense to to run the check sometimes on your packages, and it does a lot of other stuff too, obviously. Okay, where were we? Yeah. Okay, so we need to talk a little bit about namespaces and exporting functions and importing functions. I told you that there is a namespace file and that this will be automatically generated. So this file it has two purposes basically. One is to declare which of the functions and objects within your package are meant for public use and which ones are internal for yourself. Okay, so all the functions that are for public use in your package, you need to export them. Okay, so we did something wrong with the praise, right? Because we didn't export it, so how could people use it? Well, they can't in this form, right? So if I just build this praise package now that we just wrote, I build it, I give it to somebody, and they can load it with library, but they will find it empty. There are no exported functions, so they cannot call anything, in the package. So in order to, make it able for them to use it, we need to export this function. Luckily, this is a very simple operation if you have this other tool called Roxygen2, and Roxygen2 works together with DevTools. They cooperate basically. So Roxygen2 supports a notation to add a tag to functions and objects to mark them as exported. Okay, and that's the notation. Then you can see there. That's #, apostrophe, and then @export. it's a little bit, looks a little bit odd, but the point is that it starts with a hash mark because it's a comment for R, so R shouldn't interpret it, right? And then the apostrophe is there because it's kind of a special comment, so it means that this is a comment for Roxygen. And then the rest is basically the Roxygen instruction. And the Roxygen tags or instructions, they start with an @ character, and this says @export. It means that I want to export this function. So if you want to export praise, then we need to go back, right, to this file and just say, you know, export, and then save it. Okay. So if you think about it, load all is a little bit special, right? Because what happens is that when you run load all, it loads, you know, it loads all the code obviously, but it makes all the functions and all the objects available to you, not just the exported ones. Okay, that's the default, because that's just more convenient for development. But if you want to share this package, you know, build it and give it to somebody, and the other people will install it and they will use it, you know, they will only have access, you know, to the exported functions. So you need to export your functions. Okay, so that's the first thing you need to do. You add this tag that you want to export it, and then there is this is a little bit confusing, but that's the DevTools function. Okay, so Roxygen does basically all the generation and all the work, but you call it through DevTools. So the idea is that all these operations that you do on your functions, you call them through DevTools. So DevTools has a function called document, and you just say DevTools document, and it will run Roxygen and create the documentation. In this case, we haven't written any documentation yet, so we don't have that, but we have written this export tag, so it will generate the namespace file, you know, and it will put the praise function in the namespace file, you know, mark it as exported. So let's just try to do that, okay? So I'll come back here, clear the screen, say DevTools document. Okay, and you see it says writing namespace. It didn't modify anything else, but it just modified the namespace file, and the namespace file declares, you know, the praise function exported. So if I install this now and then, you know, load it, say in another R session, then I will have the praise function available. It is a good thing to export only the functions that you really want your users to use, and not everything. And that's because if you export a lot of things, that tends to have a lot of maintenance cost, because people will just basically start using those functions, and that means that you cannot really change them in an incompatible way anymore, right? So we're not exporting adjectives here, for example. Where was I? So that's an object too, right? So I could write, you know, add export on top of that too, and then that would be exported too, but we're not doing that because, you know, maybe we will have a different representation later, or we don't even know. We don't have to have a reason. It's just that the users don't need that, so we don't export that. Whatever the users don't necessarily need, we don't export. Okay. Kind of the opposite of exporting functions is importing functions. So importing functions means that you want to use in your code, in your package, you want to use functions from other packages. Okay. Now, if you're not writing R packages, not creating R packages, but you're just writing, you know, R scripts to do your analysis or to do your code, then what you do is usually you just say, you know, library, ggplot or whatever, and then you can use all the functions, all the code that is available, that is exported from ggplot2 for you. But when you're writing packages, it's good to be a little bit more careful. And that's because we don't want, you know, these different dependencies that we have, different dependency packages that we have to mix up. Okay, so the obvious case is that, you know, you need two other packages in your package. Say, I don't know, say dplyr and ggplot2, and both of them, they have a function called subset or something else, whatever, select. that means that if you just use, something like library, then it's kind of arbitrary which one you get. You get actually the last one, so if you write library ggplot2 first and library dplyr second, you get the dplyr one, and if you mix it up, then you get the other one. So we want to somehow get rid of this ambiguity, and we want to, specify exactly which versions we need, which functions we need, from which package the functions should be coming from. Okay. So there is another Roxygen tag, which is called import from, and in this example, we will use a function called glue from a package that is also called glue, and we just say, import from glue. So this will import the glue function from the glue package, and from now on, we can just use this function, in our package. We can just refer to it by its name. Okay. Okay. So this is. I'm thinking whether this should be an exercise or not, but maybe not, because you probably, unless you have glue already, you will not be able to install it, right? But anyway, so we are making the praise package a little bit, more flexible here, because what we are doing is that we will do string templating. So glue does string templating. Here's an example. You call glue with a single string that has these braced, parts, keywords in it, and that just means a substitution. So whenever glue sees these things, it will substitute the value of the R code that is included, within the braces. So this is really simple, because A is just a symbol that refers to the string this, and B is a symbol that refers to the string that. So you will just have this is this and that is that, right? In the I don't have the output here, but if you run this, that's what you will get. Anyway, so we can add templating, to praise using glue, and the idea is that you will be able to just provide, a template which has, say, a keyword called great, and then, the positive adjective would be substituted exactly at that place. Okay, or you can have multiple places, I guess. So you can have, you are great, and then it will be substituted in each. So how do we do that? Well, we need to import the glue function from the glue package, right? So we need to do basically 3 things for that. The first one is, I already told you, so we need to say, import from glue, and where you put this, it doesn't really matter so much. You need to put this somewhere in front of an object or a function, but the good practice is that you put it at the place where you use it. So if we use it in the praise function, then it makes sense to put it just above that, right? Where the export was, if you remember. So we will put it here, okay? So that's the first thing you need to do. The other thing you need to do is you need to add glue as an import, to the description file. This is a little bit redundant, right? Because, the package manager could be smart enough to look at the namespace file and see that if you're importing something from another function, then you probably want to have that, from another package, sorry, you want to have that installed, but it's not happening. It's partially historical reasons, but you have to also put it in the description file. So in the description file of our praise now, which is not here, yeah, so there is a joke that for using this editor efficiently, you would need to use all your fingers and also your feet. So I'm with one hand now, so bear with me. Okay, so I need the description file here, and you see there is no imports flag currently here, but we will just add it. You know, you can write it in one line or multiple lines. It doesn't really matter. Okay, glue, right? Yeah. Okay. And then, you know, if you think back to the check, if I run check, actually, it also checks a couple of things about the imports. You know, so if you like importing something in the description file, but you're not actually importing any functions from it, then it doesn't make any sense. So the check will tell you that you shouldn't do that, because it's like you declared this function as a dependency, but you're not actually importing anything out of it. So you probably don't want to do that, and things like that. So anyway, check is useful. Okay. I don't know how well this experiment is working, but anyway. Okay, so we added this, and then what we need to do is we need to do document. So we need to do DevTools, you know, document, and we need to do DevTools load all as well. And if you want to, you can do check, you know. So let's just do this now. Okay, I guess the templating works. So yeah, just do import from, and then you can use the function. Okay, so generating the namespace file, you know, exports and the imports and so on. So it's a little bit dark, no? So that's very handy, you know, from Roxygen, but that's not actually the main thing that Roxygen is doing for you. The main thing is, I just wonder if I can recolor this, but apparently no. So the main thing is what it's doing is generating your documentation, actually, your manual pages. So that's what we will do next. Oh, there you go. Anyway, so the idea is that let me just finish this a little bit. So the idea is that you put the documentation of a function or an object at the same place where you create the function or the object. Okay, so imagine that this is the code that we are creating the function. Then we just write this, you know, we just put this documentation, you know, in front of that. So that's how it looks like. And it uses the same, you know, Roxygen kind of comments. So it's a hash mark apostrophe that you start with, and then you can see, you know, the generic, you know, structure. So you have a title for your function, you have a short description, which is a paragraph, you have a long description, which actually not one paragraph, but it can be multiple paragraphs. So this is multiple paragraphs. And then there are a couple of tags, which also start with this @ sign, that you can use to document various parts of your function. So two of them are here. One of them is called param, which is the parameters, and we have a single parameter, right, the template. So we say param template, and then explain it, you know what it is. And then the other one is called return, which specifies what the function will return, you know, when you run it. And then from the rest, you know, you already know the export and the import from, and there is a part at the bottom which is called examples, which is pretty important actually, because it's a lot easier to start using a function if you have working examples to play with. So if you want to provide a good service to your users, then add examples to your exported functions. So we have a couple of examples, you know, for praise with or without a template. So what I need to do here now is basically copy all this stuff over to the code file, right? So this is how the code looks now, except that I should write the actual, you know, title and description and so on. And if I run document again, you see, it will tell you now it's a little bit different. Let me try to bring it up. Oh no, too much. So it's a little bit different. So it tells you now that it created this praise.rd file. So this file goes into the man folder. This is the manual page of the praise function. And you should add it to your source control and so on if you're using, you know, source control tracking. And then as soon as you do load all, you know, the documentation of this praise function is available and, you know, formatted like this. It looks a little bit nicer, you know, in our studio or in a, you know, HTML, you know, help browser on Windows or whatever. But this is how it looks in the terminal. You get your title and the description, and then, you know, description or documentation of the arguments, and the return value, and the examples in the bottom. So we can run check again. I think we did a good job, so we will not have too much breakage here, but who knows. So check. Oh, I haven't fixed the license still. So we still have that, but other than that, it looks okay to me. Yeah. So check also checks, you know, the documentation. So if it happens that you forget, say, to include, you know, an argument in the documentation. So a function has a parameter like the template, but you forget to include it here, and then, you know, you run the check on that, and you will get a warning about that. So it's really useful, you know, to write good documentation too. You see, it says right on the top, right? Undocumented arguments in documentation of object praise. So it's a template. All right, so I wrote here that the next exercise is to write the documentation of the praise function, but maybe you've done that already, I don't know. And then after that, I think we will have a break. And after the break, we will start using RHub for running these checks. I'll just show you how it works, basically. I don't think you will be able to run it without the internet. And then after that, we'll briefly talk about writing tests for your package.